just for fun, I want to talk about 3 ways to model the motion of a rigid object rotating about its center mass. So I have 3 ways to do that. Number 1 is to represent the object as a bunch of masses connected by springs. And with that, I don't have to actually do angular momentum or anything like that. I can just calculate the forces on all the masses and let it go. Okay, Newton's second law. That does work. The one problem with this is that 1, you have a lot of masses you have to deal with, and 2, you actually can't get the angular velocity vector to show how the thing rotates because it's just not possible. The next way is to use the moment of inertia tensor for a rigid object like this, and then if I assume the angular momentum is constant, angular momentum is I omega. If I use omega to find a new position, and then I can recalculate the moment of inertia, and then I can use the moment of inertia tensor and find the inverse to find omega. Now, the problem with that is sometimes you can get degenerate states where you don't really get an inverse for the moment of inertia tensor. That's a problem. The last method is to do the same thing, find that inverse. But we're going to find the inverse by taking the system in some particular initial state, finding the moment of inertia tensor, finding the inverse, and then using the rotation matrix to rotate. You have to do it twice to rotate the inverse of the tensor and then apply that to the angular momentum to find the angular velocity. So that's 3 ways to do it, and there you go. The end.